After the second part of the tutorial, we have a series of images sharpened in the Registax program. In this example, I have 7 stacked and sharpened photos that I placed in a folder labeled W. Before the derotation process, we can review these images because it is interesting to see how much rotation Jupiter made in the total recording interval of 15 minutes, from 23:55 Universal Time to 0:10 Universal Time. The WinJUPOS program will calculate and compensate for the effects of this rotation, so the result of this process will be a single image created by derotating and integrating all 7. In this way, the final image will contain a much larger amount of information and it will reveal much more planetary detail. In order to perform the derotation in the WinJUPOS program, it is necessary that the images are correctly oriented, with north up and west on the right. Since the camera in my telescope is rotated 180 degrees during the capturing, I open them all in Photopea and then rotate them by 180 degrees. After that, I save them with the commands File, Export as More, TIFF, where I include the options Attach Metadata and as 16-bit. Since Photopea stores such images in the Downloads folder, before continuing, I just have to transfer them to the working folder W instead of the ones that were upside down. At the end of the process, the correctly oriented images will be stored in the original folder. Now we can start the derotation process in WinJUPOS. The first step is to perform the necessary measurements on the loaded images. In the Program menu, select the planet Jupiter, and then in the Recording menu, start Image Measurement, and load the first image from the folder with the sharpened images, which is fastest done with the function key F7. In the Image Measurement process, WinJUPOS will map the 2D image of the planet into a precise 3D model based on the exact recording time. If we had the WinJUPOS file naming option enabled during recording in FireCapture, the recording time information will be included in the name of each video file and extracted by the program automatically, so we will not have to enter it separately in the WinJUPOS settings. Otherwise, we enter it in the Date and UT fields. Then we enter the geographical coordinates of the observing location in the Geographic Longitude and Geographic Latitude fields. Before starting the measurement, I still have to mark that I used the alt-azimuthal mount. I do this in the Options tab where I mark the alt-azimuth mount circle. If I shot with a telescope that creates a mirror image, I may also have to turn on the Mirrored Inverted Image option. For shooting with my SC telescope, I have to select Normal Image, but due to the inverted orientation of my camera during shooting, I had to rotate all the images by 180 degrees before this procedure, as mentioned before. After adjusting these basic settings, the derotation process goes very quickly. After opening each image with the F7 key, I perform the necessary measurements with the F11 key, during which a so-called outline frame is placed on the planet, which shows the position of the equator, the edge of the disk, and the satellites and their shadows, if present in the image. If necessary, we can manually adjust the outline frame more precisely with appropriate keys for moving and rotating the frame. In my work, the automatic setting of the frame works well enough, so I do not perform manual corrections. After setting the outline frame, I only need to save the .ims file with the measured data for the image in question. I do this with the F2 key, after which I only confirm saving to the original folder with the Enter key. After the first image, I perform the same procedure 6 more times, because I have a total of 7 images. I simply repeat the sequence of 4 keys, F7, after which I select the next image from the folder, then F11, then F2 and finally Enter. When all the images have been measured and their data has been saved, I proceed to derotation and integration of all 7 images. In the Tools menu, I select Derotation of Images, Since the program remembers data from previously derotated images, I have to remove them first. In the Derotation of Images window, I click on the Edit button and select Remove All and confirm with the Yes button. After that, with the Edit and Add, I select all the .ims image files that will be derotated and integrated. Before starting the derotation and integration process, I can check and edit some data about the final derotated image if necessary, which I do in the left part of the window. I find the quadratic image size and image orientation options useful. For the latter, I choose North at top. Finally, I click on the Compile Image button or the F12 key. With this, I start the derotation and integration process, the result of which is a derotated image in a small window. The image is automatically saved in the original folder, but if you wish, you can save it in another location and in another format. That image now contains more information than any of the images it was created from. In the next and final part of this tutorial, I will show my processing workflow in Adobe Photoshop CS2, which I will use to highlight as many details as possible in this image, without distorting its natural appearance.